Now, let's take a look at variable declarations. Suppose you are looking to hold 100 ml of water. First of all, what will you do? You will take a glass or a bottle which is capable of holding the quantity. Similarly, when you are looking to store a value, you first need to obtain the memory block which can hold that value. For example, in the below statement, we allocated an integer block of size 4 bytes in memory. It can hold some integer value in it. Here, A is called an identifier for that block. Whenever you are referring to A, we mean that we are referring to the memory block associated with A. The assignment statement A equal to 5 will store the value 5 in the block allocated for A. When we say A equal to 7, it will replace the value of A with 7. You are able to change it because this memory block is changeable. Hence the name variable. In full, we have to say A is an integer variable. That is, a memory block which is capable of storing an integer value and it is changeable. Opposite of variable is a constant. A constant, as the name indicates, once initialized, it cannot be modified. For example, final int b equal to 5. In this case, the value given to b is final and you cannot modify the value post initialization. If we try to assign a different value to b, compiler will reject this assignment because b is declared as final. Hence, it is constant. It cannot be modified after initialization. Now let's see what are the best practices followed while naming the identifiers. For a variable name, we start with lowercase letter and we will capitalize the first letter of each word within the name. In the below example, we declared a variable total count. Within that, we used lowercase for the first letter and capital case C for the next word. Give proper names for the identifiers so that they represent the kind of value that they are going to hold. This notation of changing each subsequent word with capital letter is called camel notation. It is extensively used in Java. In case of constants, we use only capital letters and each new word is separated with an underscore. As you can see in the below example, max count is all capital and max and count is separated with an underscore. This way, when we are analyzing an expression, we can predict if it is a variable or a constant. A small test for you. In the below expression, classify the identifiers whether they are variables or constants. I'll give you 5 seconds. Yes, x is a variable. Y is again a variable. A is a variable. Max should be constant because it's all capital. Let's take a look at literals. Literal is a source code representation of a fixed value. In simple words, it is a direct value which is present in the expression. In this expression, 10 is said to be a literal value. Even the literals should be given a type as they might be stored in memory. Let's see what are the data types associated with literals. By default, 100 is taken as an integer. With suffix L, it is treated as long. When you take 10.23, it is treated as double. 10.23f, that is with suffix f, it is treated as float. Also, integer literals could be represented in 3 different formats, that is decimal, hexadecimal and binary. In this example, 26 is written in decimal form. When we prefix 0x, it means it is a hexadecimal number. When we prefix 0b, it means it is a binary number. Binary format is supported from Java 8. For floating point numbers, we can either directly specify a value or we can use scientific notations for that. When we say 1.234 E2, it is equivalent to 1.234 into 10 square. Character literals are enclosed with single quote. You can also represent special characters with escape sequence /t for tab character, /n for new line feed, /u for specifying Unicode character. String literals are enclosed within double quotes.